an example of the continuity equation in fluids. So let's imagine that we have a tube system where the initial fluid is coming into an initial tube that has a diameter of, or a radius of 5 millimeters. It then moves into a larger diameter tube, a radius of 10 millimeters, and then it goes into a even smaller diameter tube with a radius of 2.5 millimeters. So these are all radii, these values here in my tubes. And in this initial space, in this initial tube, the velocity of that fluid is 4 meters per second. So let's look at what is the velocity and how does it change as it goes through each of these segments in this piping system. All right, so the first thing we want to do is identify the 3 segments. So we're just going to mark these as our 3 segments. And we're going to examine the law of continuity as it goes through these 3 segments. So remember that that continuity equation is the speed in a segment times the area of that segment is going to equal the speed in the adjacent segment times the area in that segment to maintain bulk flow. Okay. So we have, these are circular tubes, so we want to keep in mind that the area, cross-sectional area, is equal to pi r squared for a circular shape. All right, so let's utilize that relationship to find the different speeds. So let's go from 1 to 2. So as we go from 1 to 2, we're looking at the speed in 1 times the area in 1. This has to equal the speed in 2 times the area in 2. And we're interested in that speed in 2. So that is the speed in 1 times the area in 1 divided by the area in region 2. So we're given that our speed is 4, our area is pi times the radius 0.005 squared divided by the area of section 2, which is pi times 0.01 squared. So the speed in our second segment is 1 meter per second. So let's just double check that calculation to make sure my notes are correct. So our pi's are going to cancel out. We have 4 times 0.005 squared divided by 0.01 squared. Sure enough, 1 meter per second. So our speed in that second segment is 1 meter per second. All right, so now let's look as we go to that third segment, and we can use the second segment information. We have our speed in segment 2 times the area in segment 2 has to equal our speed in segment 3 times the area in segment 3. So the speed in segment 2 times the area in segment 2 over the area in segment 3 has to equal our speed in segment 3. So our speed in segment 2 was 1. Then we have pi times 0.01 squared divided by pi and 0.0025 squared. And if we do that calculation, again, the pi's cancel out, so we have 0.01 squared divided by 0.0025 squared, and we get our speed in that third segment at 16 meters per second. All right, so just utilizing that continuity equation. Now, one of the things we said about that continuity equation was that this helps maintain the bulk flow rate. So let's just look at the bulk flow rate through each of these segments and see if that works out for us. So how do we get the bulk flow rate? Well, the bulk flow rate is our speed times our area. So how fast we're moving through a given amount of time. So the bulk flow rate, remember, is Q, as our bulk flow rate, is the speed times the area. Now, we kept setting these equal to each other, so this should work out pretty slick. All right, so for segment 1, the bulk flow is 4 times pi times segment 1 squared. So the bulk flow in segment 1 is 4 times pi times 0.001 squared. 1.26 times 10 to the minus 5 meters cubed per second. All right, let's see. Did we do that correctly? I think so. 0.005 squared. Oh, nope, I did 0.001 squared. I'm looking at that going, that is not the number I expected to get. So I just plugged it into my calculator wrong. So that is not the right number. This is correct. 4 times pi times 0.005 squared. That looks like what I expected it to be. 3.14 meters cubed per second should be our bulk flow rate for all three sections. Let's just confirm that. The bulk flow rate for section 2 should be the speed in section 2 times its area. So we have 1 times pi and 0.00, too many zeros, 0.01 squared. So we get pi times 0.01 squared, and we find that indeed 3.14 times 10 to the negative 4th. I missed that over here. Sorry about that. Meters cubed per second. Meters cubed per second. And similarly, again, to just verify that continuity relationship, the bulk flow in area 3 should be 16 times pi times 0.0025 squared. And if we confirm that, we indeed get 3.14 times 10 to the negative 4th meters cubed per second. And we better, right? So the whole reason that the continuity relationship holds is because we have to have a bulk flow rate similar as the fluid flows through different sections. All right, good job.